Hi students, welcome to Alpha C learning program. In previous sessions we have started just the concept of normal. What about equation of normal? Okay, so what is equation of normal, students? It is nothing but y plus xt is equal to 2at plus at cube, and this is exclusively to the parabola y square equal to 4ax. Okay, to the standard form y square is 4ax. We have observed this is equation of parabola drawn at the point t. Okay, now and we observed for x square is 4ay, what happened, and again here for y minus beta whole square is 4a into x minus alpha. Just here replace y by y minus beta, x as x minus alpha. Like that we have observed different categories of these normal equations for under different conditions to a parabola. Now here suppose this equation, if you observe, you know clearly what is the slope of this normal. Slope of this normal is clearly how much it is, minus t. Okay, slope of normal drawn at t. Okay, drawn at t is nothing but how much we got, minus t. And suppose you take minus t as equal to m, then the same equation we can write as here y minus mx equal to, this is minus 2am and minus am cube. Okay, m value or t we substituted how much here, minus m. So wherever t is there in this formula, if you substitute minus m, this is the value. That implies y equal to mx minus 2am minus am cube. We can say here this is equation of normal whose slope is m to the parabola y square is 4ax. Again, if the parabola is x square equal to 4ay, just interchange x and y. That is x equal to my minus the remaining is as usual. And if it is vertex is alpha beta, then y minus beta here, m into x minus alpha here. So every time same changes only we can follow. Now you can say clearly this is equation of normal whose slope is how much here, m to the parabola y square equal to 4ax. Suppose a problem is given, if slope of normal, okay, if slope of normal drawn to the parabola, slope of normal drawn to the parabola, it is given as, suppose this is given as here 3, okay, to the parabola y square equal to 8x. Then directly we can substitute, no need of here point etc. Here m is given as how much, 3, m equal to 3 and a equal to here we are having 2. Okay, then the formula if you write y equal to mx and minus 2am, that means it is 12 minus 2am, and next value minus a into m cube, that is here 27. So in this way if I write this is 3x minus y minus 54 minus 12, we can write that is minus 66 is equal to 0. So clearly students, this is nothing but equation of normal drawn to this parabola y square equal to 8x whose slope is given as how much, 3. So directly you can substitute in this formula. Okay, so whenever it is given, suppose x square equal to 8y, okay, suppose the problem is given as here x square is equal to 8y, then what about here equation of normal? Just to interchange these values, that is x equal to my, remaining are same, minus 2am minus am cube, right? And now x is equal to, m is given as here 3, so 3y minus, again these values are same only. So a equal to 2 here, 2 into 2, this is 3 minus 2 into it is, this value we got how much, 2 cube. Okay, so in this way we can write here the formula for this one, that is here m cube, sorry, this is here 3 cube. So you can write here formula for this equation also. X square is 4ay given or anything given, simply you can make use of the slope formula. So slope is enough and equation of curve is enough, and if you know about these two, simply we can write equation of normal. Now sometimes students they ask about here, just like our previous chapter circle, suppose here a line is given, so with some unknown, then what is the condition that the line to represent a normal? Okay, If it is a circle, no such restrictions are there. Now you know clearly if it is a circle, we know clearly that normal always passes through here center of the circle. Okay, however the tangent you consider, but normal always passes through center of circle. Just basing on that concept we have done normal problems in circle. Whereas in parabola it is not the case like that, so you have to do in some other way. So whenever a line is given, that is Lx plus my plus n equal to 0 is given. Okay, if a line is given, now the question is what about here? The condition that this is a normal to a parabola, y square equal to 4ax. Okay, if it is normal to the parabola, y square is 4ax. Just let us know how you got. It is just only 3 to 4 lines, and thereby however the parabola given, you can make use of the formula. If this is standard form, if you remember, it is well and good. Now what is the approach actually? The approach is nothing but here we write here at t. Okay, at t the equation of normal, at t the equation of normal to the same parabola, and this is nothing but what is our formula, students? Y plus xt is equal to 2at plus at cube. You can make use of any formula. If you are comfortable in writing m value, you can use our t value also we can use, right? And now if this is the normal equation, that implies we write xt plus y, and it is minus of 2at plus at cube equal to 0. Okay, so this is equation 1. If I take, this is the normal we got using the formula which is at t on the parabola. Now but this is actually given normal, that is Lx plus my plus n equal to 0. This is actually given normal, but both are representing what here? Same line. Okay, this one here a tangent you got, and this is the normal we got, and according as formula we found just now, but already they said this normal is how much here? Lx plus my plus n is 0. Okay, so one value you got by formula which is already given, implies both the equations are representing here same line. When two equations represent same line, then their corresponding coefficients are in same ratio. So if I write those values, this is t divided by L equal to here 1 divided by m. Okay, and next value this is equal to, the other value we can use, it is minus of 2at plus at cube and divided by this is n. Okay, now if you compare, first I am taking this is here t equal to L by m. Okay, so here if you compare these two, t is clearly L by m, and after that if you compare these two, okay, and now this minus sign, let us take this side, that implies it is minus n divided by m. Okay, and this one is here 2a into t means I am writing L by m, and next this is a t cube, that means I am writing plus a into L by m whole cube. Okay, now if you simplify, this is implies minus n divided by m equal to, now this value is 2al divided by m, and next this is equal to plus al cube divided by m cube. Okay, and now this side let us take here LCM as m cube. Then what will happen here? If I take LCM there, then the value is nothing but here minus n divided by m is equal to this side m cube. I am taking LCM, therefore it is nothing but the value 2al m square. Okay, 2al m square, and after that this is plus al cube. So this is plus al cube. So what we have taken here, simply t equal to L by m, and this value you got, this is 1 by m actually here, this is 1 by m we are equating, and n we have taken cross multiplication, so n divided by m equal to, but we send here minus symbol, so minus n by m, and here 2a into t means we substituted L by m, and plus a into the t means L cube by m cube. Okay, now we have taken this side m cube as LCM, and this is here how much, students? You got m cube. Okay, now if I take cancel this m square here and do this side, that implies minus m square n equal to 2al m square plus al cube, and if you take this value also this side, simply you got this condition, that is what is the condition? Al cube plus 2al m square and plus m square n equal to 0. Okay, therefore whenever a line Lx plus my plus n equal to 0 represents normal to the parabola y square is 4ax, this is our condition. And if it is a circle, all of you know very well, the normal always passes through center, so simply we can make use of that condition, right? And now how they ask in problems, actually you know very well. In problems, if at all they ask the condition, they ask as suppose some line x minus y plus 3 equal to 0. Here suppose k is 0 represents, that means this line is a normal to a parabola, suppose y square equal to 4x. Okay, then our condition a value is here 1. Okay, a value is 1 and next here L is 1, m is minus 1 and n equal to k. Then we substitute all these values in the condition, that is al cube, that is 1, and next plus 2a lm square. So 2 into a into l into, okay, m square. So again you got here plus 1. 2al m square plus m square n, that is k equal to 0. Therefore k value we got how much? Minus 3, and that we substitute here. So students, in this way we can find here normal condition. And next one is we have an interest, that is what about here normal drawn at the ends of latus rectum, because always in many cases we have observed latus rectum is playing a very vital role. Therefore our interest is what about here normal, that means here drawn at the end of latus rectum. So what are ends of latus rectum, students? This one is here a comma 2a. Okay, this is one end of latus rectum, and clearly you know here what is the t value? It is 1. Okay, to the parabola y square equal to 4ax. Therefore what about here equation of normal? The normal is nothing but formula y plus xt equal to 2at plus at cube, right? And now if I substitute this t value 1 here, y plus x is equal to 2a plus a. That implies x plus y equal to 3a is our normal equation drawn at the end of here latus rectum, one end of latus rectum. Then immediately we may get one doubt. What is the doubt actually? Whatever the normal you are taking, is it completely the latus rectum or is it any other line? Suppose if you got that one, you observe here clearly it is not at all passing through the focus. Okay, a comma 0, if I substitute here, this line is not passing through focus. Therefore whenever you have taken normal at one end, so this is our normal at one end. Okay, it is not passing through focus. If it is meeting, suppose here the x axis value, that means x axis, clearly you know y is 0, x equal to 3a. So if a is here, students, this one is here 3a comma 0. Okay, therefore normal drawn at the end of latus rectum cannot pass through again focus. Moreover, one and only one important thing is there, that is whatever the normal you have taken that can pass through focus is only one normal exists, and that is nothing but here exactly axis of parabola. Okay, if this is tangent at vertex you have taken, this is exactly tangent at vertex we are taking, then perpendicular line is nothing but what here axis. So there exists one and only one normal that can pass through here focus of the parabola. Okay, whatever oblique or whatever case it is, you can understand this is a very clear point, that is there exists one and only one normal which can pass through focus. Okay, and that is nothing but what here axis of parabola. Therefore you can understand latus rectum, whenever at one end if you take here the normal, it cannot pass through focus. In the same way, students, if you take here the other normal, that means here at a comma minus 2a, okay, the other end of the latus rectum, other end of latus rectum is a comma minus 2a, and here what is our t value? Minus 1. Okay, t is minus 1 if you compare 2at. Okay, t is minus 1. Here y plus xt equal to 2at plus at cube if I write, then what is the value? Y minus x is equal to minus 2a minus a, implies I can say y minus x is how much? Minus 3a. Therefore normal drawn at the other end of latus rectum is nothing but x minus y minus 3a equal to 0. Okay, and this is the other normal you got. This is x plus y minus 3a equal to 0. Okay. So these are the two normals and one relation you can observe. These two are here mutually perpendicular. So what is the clear point we observed, students? Normal drawn at one end of lattice rectum cannot pass through the other end of lattice rectum. Okay, cannot pass through the other end of lattice rectum. Both the normals are here different. Okay, so if I take here the other end a comma minus 2a, then this one is nothing but what here in this way. Here also if I take y is 0, what is x value? 3a. Both are intersecting at what point here? 3a comma 0, and moreover they are at right angle. Okay, so this is the special case, students. What about here? Normals drawn at the ends of lattice rectum. One is this x plus y minus 3a 0, and the other one is x minus y minus 3a equal to 0. So this one we did till now, the normal drawn at ends of lattice rectum. Okay, and next one is other interesting point is there. Just now you have observed the diagram. Whatever the line I have taken normal and I did not ending it. Okay, if I end somewhere, suppose we are taking, this is the parabola I have taken, students, and now we have taken here one tangent. Okay, correspondingly if I take normal, just we are leaving like this. This is 80 square comma 280 to the parabola y square equal to 4ax, right? And now if you continue this one, okay, continue this line meets the parabola somewhere here. Okay, somewhere. So if I continue that one in this way, this line is meeting the parabola somewhere at some point, but it will meet, no doubt it will meet. This line is known as here normal chord. Okay, so what is normal chord? The normal drawn at a point T. Okay, at a point P or T, whatever you can say, the normal drawn at a point P meets the parabola again at another point, suppose Q, then PQ is nothing but what here? Normal chord. There are chords also. Suppose if I take here, this is also a chord. But here this chord I am not giving any significance, just I am telling the line joining 2 points P and Q. Then what about normal chord? Normal chord means here exactly you have taken a tangent and again here you are taking a normal. That means these two lines are here perpendicular. Under that one, if you extend this, it is meeting the parabola again at another point. Then we say PQ is nothing but here normal chord. Once students, normal chord means here, suppose I have taken P is 80 square 280 and here you have taken normal, these two are perpendicular. Then don't expect that here whatever normal you drawn at Q and Q suppose some alpha beta, normal drawn at Q is need not be, that means this is not this line. Okay, normal drawn at Q is different, but normal drawn at P is different. Once this is normal chord, clearly understand the normal drawn at the point Q cannot be again the same line. What is that one? Some other. That means if I take a tangent here, then this is our normal. Okay, this is the normal. That means it is different. So you have to take the clarity very clearly. Whenever normal drawn at T, if it is meeting the parabola at a point Q, then normal drawn at Q again, not again the same line, but it is some other line. Okay, it is some other line. A very, very important point. Okay, now how to find here exactly Q coordinates? If it is focal chord concept, students, what happened? Focal chord concept here, whenever a chord is passing through focus, okay, a chord is passing through focus, then if I consider here a point P and this is the other end of the chord, then PQ are end points of a focal chord. That means here normal whatever focal chord you have taken this side, again if I take focal chord Q, this is the same thing. It is not some other line, because here the condition how much you got, T1, T2 is -1. If you take T2, it is -1 by T1, or if you take T1, it is -1 divided by T. So while taking focal chord, students, you can observe here focal chord drawn at P meets the parabola again at Q, again focal chord drawn at Q meets the parabola at P. Okay, so these are just internal relation, but the thing with normal is not like that. Okay, so let us observe now. Suppose a normal is drawn at one end T, then where it meets the parabola exactly. Okay, so this is the formula. If normal drawn at to the parabola y square is 4ax at T1 suppose, then it meets the parabola again suppose at a point T2, then T2 is nothing but minus T1 minus 2 by T1. Okay, so how the proof? Let us observe. Very less number of steps actually. Suppose this is the parabola we have taken and normal drawn at this one is suppose tangent a T1 square comma 2a T1, and now we are taking normal drawn at this point. Okay, normal drawn at this point, suppose this is our Q of T2 and we know this is a T2 square comma 2a T2, but what is this T2 value exactly in terms of T1, that we want to know. So what is our formula, students? Actually the formula is nothing but for normal equation it is nothing but what? Y plus xt equal to what is the value? 2at plus at cube. Okay, y plus xt is equal to 2at plus at cube. This is our formula and we are taking this at T1. Therefore I am writing here T1 and this also T1. Now this normal is passing through which point? A T2 square comma 2a T2. Okay, this normal passes through the point Q here, that is here, then you substitute this value 2a T2. Okay, plus here a T1 square, this is T2 square T1 equal to 2a T1 plus a T1 cube. Now I am writing here this value this side and this side, and thereby you can obtain 2a T2 minus 2a T1, and this side you got a T1 cube and this is here minus a T2 square T1, right? From here we can take 2a common, thereby it is T2 minus T1, and here you can take here T2 is coming first, therefore I am taking minus a, this is T1 we are taking common. Okay, then this value how much you got? This is T2 square minus T1 square. So in this way you got, then this one a and a get cancelled here, a and a get cancelled, and now you got here 2 into T2 minus T1, this is minus T2 minus T1 and into T2 plus T1, right? And now let us cancel these two also, because you know clearly T1 is not equal to T2. Then how much you got here? This is 2 equal to, what is the value you got here? Minus, this is T1 already there here, so 2 divided by T1 I am writing, so you got now minus T2 minus T1. Okay, 2 we send to denominator here, and this side you got minus T2 minus T1. Now you multiplied with this value. Therefore students, I am sending this T1 also this side. Then how much we got here? It is 2 by T1 plus T1 equal to how much? Minus T2. Finally the T2 is nothing but how much here? Minus 2 by T1 minus T1. Okay, therefore if normal drawn at T1 meets the parabola again at Q, that is at T2, then T2 formula is minus T1 minus 2 by T1. So one of the important cases, if it is a focal chord, then easily we said T2 is minus 1 divided by T1. Whereas if it is a normal, then you have to understand the coordinates you can obtain by writing T2 as how much here? Minus T1 minus 2 divided by T1. Understand? Now what is our doubt actually? If I take normal at T2, okay, then the normal at T2 need not be, that means it cannot here pass through this point. That route is separate and this route is here separate. Okay, so let us observe even here if I am writing any, let us take one example students here. Suppose normal drawn at a point, okay, normal drawn at a point, let us take end of latus rectum at a comma 2a. Okay, so here what is our t value? T is equal to 1. Understand? That means let us take T1 is 1. Now here what is T2 value? T2, now we observed the formula, it is minus T1 minus 2 divided by T1, okay. That implies minus 1 minus 2 divided by this, that is minus 3. Understand? Now, what is AT2 square comma 2AT2? Because this is the point on the parabola. So, this is 9A, okay, 9A comma this other value minus 6A. Understand all of you? 9A comma minus 6A. Therefore, whenever normal drawn at one end of lattice rectum A comma 2A, then it meets the parabola again at what point? 9A comma minus 6A, okay, again at 9A comma minus 6A. So this one you got, students. Understand? So just now what we have done here, if this point is clearly, what is the point we have taken at one end of lattice rectum, okay, normal drawn at one end of lattice rectum, that is meeting. So if I am taking this is A comma 2A, and now this point is meeting the parabola again at what point here? 9A comma minus 6A. Understand? Observe, if at all you want, what is the parabola equation we are having here? Y square equal to 4AX, okay, y square is 4AX, and if you substitute here, this is 36A square, and this one also here 36A square. Now we may get a doubt. What is our doubt? If normal drawn at this point, will it passing through this point or not? Let us start again the problem from here onwards, okay. So minus 6A we have to compare with what actually? 280, okay na? So here I am comparing. So this one is how much? This is T equal to what? Minus 3. Understand? Now T equal to minus 3 means what is our formula? 80 square comma 280. So what is 80 square comma 280 here? This is nothing but here 9A comma what is the other value? Minus 6A. Okay students, so this one you got T value. This is only we got T is minus 3. Here we got this one. Suppose I want to take here T is minus 3, but I am taking here, that means T2 is minus T1 minus 2 by T1 I want to write. So T2 is minus T1 implies 3 and minus 2 divided by T1, that is here 3. So what is this value here? 11 divided by 3, okay. Now what is the new point you will get here? The new point is AT2 square 2AT2. The new point is nothing but A into, it is 121 divided by 9 comma 2A into 11 divided by 3. So clearly it is going, this is the tangent here, the normal is going again this side. Understand? Both the coordinates are positive, so it is going towards first quadrant. So clearly understand students, whenever normal drawn at one end of any curve, that means one end of lattice rectum or at any point T, if it meeting the curve again at Q, the normal drawn at Q cannot pass through again the same point P, okay. So this is clear cut. Now what is our interesting point? Next thing is nothing but here, what about here? Length of normal chord, okay. So what is length of normal chord? And already you know students very well, we have done many times the length of chord concept. So here also we want to make use of that concept, okay. So what is the length of chord? Actually joining 2 points, okay, joining 2 points T1 and T2. So what is the formula here? Length of chord joining 2 points, the formula is A into mod of T1 minus T2 and into under root of 4 plus T1 plus T2 whole square, okay. So this is formula. Suppose if I take this is P and Q, okay. Now this is our length of chord PQ, and now I have taken suppose tangent at T1, okay, tangent at T1, and it is meeting the parabola at T2, okay. So tangent is drawn at T1 and it is meeting parabola again at T2. So here tangent is drawn at P of T1 and this is the normal and it is meeting the parabola at Q, okay, of T2. So what is our formula students? T2 is minus T1 minus 2 by T1, that is our formula. And now here I want to substitute this relation. So as we are having T2 is minus T1 minus 2 divided by T1, okay. Now what is this condition? Here I am writing, that is A into mod of T1 minus t2 implies plus t1 plus 2 by t1. Okay, here I substituted. And next again here under root of this is 4 plus, okay, t1 plus t2, just take this side, t1 plus t2. So this is here 4 divided by t1 square. Understood all of you? So what is here t1 plus t2 value? t2 plus t1 is equal to minus 2 by t1. So if you take square value here, it is 4 by t1 square. That implies this PQ length is nothing but A into mod of this is 2t1 and plus this is 2 divided by t1. And here you got how much this value? Under root of 4 value if you take common, it is 1 by t square plus this one. So let us take here, this is 1 plus 1 by t1 square. Okay. Now here and here both the sides, let us take LCM. From here you will get 2 common, here also you will get 2 common. So 4a into it is mod of t1 square plus 2 divided by t1. And here also under root of t1 square plus t1 square plus this is 1 divided by t1 square. So finally how much you got? 4a into 1 plus t1 square to the power of 3 by 2 divided by the denominator you got t1 square. Hence in general if I say the normal drawn, okay, normal drawn at t meets parabola at some point, then length of normal chord, okay, length of normal chord is equal to, what is our formula here? Length of normal chord equal to 4a into 1 plus t square to the power of 3 by 2 whole divided by how much? T square. So this is formula for length of normal chord, students. A very important formula. Whatever concepts you are getting regarding normal in parabola, that is very important. Parabola means actually we can say normal concept. Okay.